time, which itself is a big achievement in many events that I go to. And I would want somebody to be the timekeeper, because the schedule is that this is 9:30 to 10 my comments, and 10 o'clock onwards we begin with. I think the first speaker is Kainer Sachdev, right? किसका नाम लिखा प्रोग्राम में देख लीजिए। हाँ, उसके बाद सेकंड कॉर्नर का I don't see him here. हाँ, तुम पढ़ के बताओ।
Kapil
Mode, is Kapil here? Not yet. तीसरा कौन है? वो भी नहीं आई। चलो चौथा
Manish Kumar.
he is here. चलो, so we at least have the session started, though the order may be changed. See, this is not a very unusual thing, because it takes time for people to come. They can't estimate the amount of time, etc. and so on. So let me begin by a very great good morning to all of you, and I'm really delighted that you could find time to come here, because it's a Saturday morning. It takes a lot of effort. People have come from far away distances. George Eapen is actually coming from Pune, so he's still trying to have his bath, etc. Shishir has come from very far. Sanjay Sinha has moved a little bit from Bombay to be here for this, and so on. In this half an hour, I want to say some general comments about the what, why of this is what is happening. I was reflecting to myself. This started off about a month back when I created a group and sent messages, and we added people, and I created a tentative program. And originally the program was that there will be just 2 or 3 speakers like myself, and we hold the day. And as we found more people who have done real work and are interested, we added more speakers. And so now we have about 15 speakers, each of which will speak for about 15 minutes, and that also is cutting short their time in terms of what they have to contribute. So why was this event created? There's a very interesting book called The Cell Phone Nation. If you haven't read this book, Google this book, Cell Phone Nation. This was written around 2014-15 or something by 2 people, one from Singapore, one from Australia, and was about this disruptive effect which cell phones have had in India. At that time the number was like 90 million or something, a very small number, but it talked about how the cell phone is the disruptive technology which is fully transforming India, and it's called the Cell Phone Nation. There's lots of data stories of what we might call prehistoric times. But the part which I found interesting about the book was that they said that many people have asked that, for whom have you written this book? And they gave the answer, we wrote this book for ourselves. And this event I have conducted for myself, so that I am interested in this field, so that I have sort of, get to the minds of other people, etc., etc. So this event has been created for me, and all of you are either willing or unwitting victims to this strategy plan of mine to be able to learn about AI and its various implications. Why this topic? It's amazing. See, all of you have heard of or read of Shatranj Ke Khiladi? So we are exactly in that same position. There is a set of people, at that time it was the British, who are coming, and we are going to be challenged by them, but we are busy with our other thing, whether Maharana Pratap was greater or Akbar the Great was greater, or various issues of this kind. And it's quite interesting, because while in that Shatranj Ke Khiladi, it is the British who won against us. The British themselves missed out when Hitler was coming to power. So Winston Churchill wrote a number of essays on whatever, and they were published eventually as a book called While England Slept. And they said that actually England was sleeping while Hitler was being built up, and was actually contributing to the build-up of Nazism and Hitler in particular. John Kennedy, when he was studying in the US, he was very fascinated with this analysis, and the statements are not private remarks to somebody. These were letters as a parliamentarian to Parliament and so on, but they were duly ignored. And then John Kennedy wrote a book called Why England Slept. So he talked while England slept, he said why England slept. And my worry is why India is not waking up. And this is what has got me to start looking at this. I'll share with you a few facts. 2015, our Science Bharat Ratna, Professor C.N.R. Rao, who was my colleague in IIT Kanpur, said in Rashtrapati Bhavan, that 90% of university curricula are out of date. Since that time, nobody has either said that he was lying, it is not 90%, only 87%. Nobody has challenged. Nobody has said, take away his Bharat Ratna. He's a traitor, he's anti this thing, we are doing such a great job, and this thing. Nobody has, they just ignored him. Somewhat like our Shatraj Ke Khiladi story or whatever. And in fact, that our poet Kumar Vishwas is more famous for talking about Chanakya and Nand, and the story that Chanakya was trying to wake up Nand to something, but Nand said, you get out here, nothing to do with it. This is the interesting part. There are many reports, including the recent one, and that is what I am most excited about. Chairman AICT has said, there are no jobs for engineers in the future, there is no jobs for MBA in the future. Why are you regulating, why are you shouting non-AICT approved, when you are yourself saying that there is no opportunity for all these people? It is amazing that you run this for years, so much, newspaper, how many ads, regulated institute, unregulated, and now you are saying there is no opportunity for all of you. Which is completely stupid, because we know we are moving towards a more technological society. And to say that in that technological society, when people are talking of blockchain and Internet of Things and so on, there is no need of engineers and no need of managers, only reflects upon what you have been creating and labeling as engineers and managers and so on. There is a statement by Mohandas Pai. Come in. So Mohandas Pai, that we have 10 crore young people with skills which are of no relevance to the world. And the population data is we add 1 million children who turn 18 every month in this country. That is about 1.2 crore a year of 18-year-olds. And the total population of Australia is about 2.4 crores. The challenge is huge, but nobody seems to be looking at it. And this is where I felt that the only way of getting around it is for people to take charge, at least of their own children and nephews and nieces and grandchildren, if not of the rest of the country, because the country seems to be nobody's responsibility. Why did I begin with the cell phone nation story? To me, mobile phones are the answer. If you want to reach to all the people, they already have mobile phones. The mobile phones are already smartphones. We learned how to use smartphones without any, many of my IAS friends, that you missed a great opportunity. You would have had a Director General of Mobile Phone Training, Additional Director General of iOS Training, Additional Director of Android Training, and then you would have created so many of Common Services Center where you would go to learn about mobile phone, show your Aadhaar card, which would have been linked to it. So much bureaucratic opportunity you missed because we learned it by ourselves. And this is my main attempt, that can we learn AI and machine learning and blockchain and big data and Internet of Things by ourselves. And if we can do that, at least for those people who do that, there will be a big opportunity. Others can follow, we have no quarrel with them. So for example, if some schools really want to do this, some state schools want to do it, by all means they can, but we shouldn't wait for government to do this first and have some policy written by somebody, etc., for this thing. So this is the mentality. Now when we look at the issue of why has AI become suddenly so important, many people I talk to assume something about AI and start commenting on it without having understood what is really happening. So one of the, please come in. Yes sir. So one of the things is to be able to really understand what is it that is the transition point between traditional computing and AI, what can AI do today, and of course what needs to be done. So when you look at education, you actually have three concerns. What is it that you want to teach people? How would you teach them? And where would you teach them? It's a very interesting story. And now we've got much more audience, so I can finish at 10. Somebody should point out that it is about to be 10 or whenever. So there's a famous story of Albert Einstein. So Albert Einstein was a great physicist, you know, and once upon a time he was a professor at Indian Institute of Advanced Studies in Princeton. And as happens in all teaching situations, there is a time to hold exams, and typically big professors have teaching assistants with them. So he created an exam paper, gave it to his teaching assistant for further action, if you might say. This teaching assistant is not exactly illiterate or ignorant. He reads the paper, he comes back. But sir, this is exactly the same question paper that you gave last year to the same set of students. And Einstein coolly said, yes, I know. The question paper is the same, but the answers have changed. And I think this is what I want to draw attention to. The questions are still the same. What do we teach? How do we teach? Where do we teach? But the answers have changed. We no longer teach an AICT curriculum because AICT has acknowledged that we don't know anything about. We didn't know anything about the past, forget us knowing anything about the future. The University Grants Commission has been disgraced recently by the government itself. And it's so amazing. They have their chairman, vice chairman, everything, but they've said this is useless. And therefore we will create another body. And this body will be empowered with criminal powers. So they will be able to do now. Can anybody say that all the diversion we have between what students have learned and was because of lack of criminal powers, because we could not send the directors of institutes to jail or something? It wasn't, but they are going to do that. Which means that we have to figure out what is to be learned, how we learn it, and where we learn it. And the purpose of this deliberations is a step in that direction. So we hope that at the end of this thing, we will probably be able to come to some of these things. Now, what Einstein said was in the context, and perhaps the year must have been 1905, 1906 or 7, when he discovered the theory of relativity and so on. In fact, that year, it's called Annus Memorabilis, Einstein produced 4 papers, each of which was worth a Nobel Prize. One of them was on the Brownian movement, one was on the photoelectric effect, one was on the special theory of relativity, one was on the general theory of relativity. We are also at a similar transition moment where there are fundamental changes in almost everything. So there's a lot of progress in terms of how we learn. We know that AI can do face recognition, it can do speech recognition, it can do so many other things. We know that we can train machines through supervised learning, unsupervised learning, reinforced learning, and so on. And therefore, the impact on how we would teach humans is very visible. So now you actually, if you can go and train a set of hardware to do certain things, why can't we train human way to do better? And these become very important questions in terms of, the point is therefore that field actually helps you in terms of learning. So what are the challenges to education today? The challenges to education today are, according to me, I'm talking broad ones, not the narrow thing which we. The first challenge is the challenge of numbers. I just reeled out that there are 10 crore with 1 crore added every year of young people in their 18 to 20s who need to be educated for alignment to the world. I'm not using employment word or whatever, but for alignment to the world so that they are useful. So it's a question of large numbers. Our response typically is to create one institute. So we will say there is one institute of AI created by Niti Aayog, we will give 200 crores there and it will give BTech degrees to 40 students per year and over a 4-year period. And I'm saying this because I just now helped the University in Ludhiana design a curriculum for MTech program in AI and machine learning, and they are going to intake 50 students. Is nowhere near looking at the problem. So the first part is that whatever is there is a system of massive education. Anything, see all AICs are 40 students, 60 students, 80 students, all nonsense. Anything which trains less than 10,000 people in a field has no impact. It may be interesting because these are specialists who want to learn a niche. But if you want people who are useful in quote unquote modern terms, nothing less than 10,000. And this myth of small class sizes has come because of a wrong methodology. Very often they say exception proves the rule. Look at Ramdev. He has taught yoga to how many people? Did we have yoga teachers for every 20 students in every class 3 times a week, etc.? So that proves the thing. But I will tell you, because you are all very educated, the fundamental principles. You see, if your teaching method is for small group, So I'm used to the Upanishad method of teaching, and I teach one person, right? Like Sanjay is there, I'm teaching him very well. The moment Bhupesh comes, my quality deteriorates. And if Professor Suresh Chandra is also sitting, I'm so awkward that I just can't teach at all. And so we created this small group of homogeneous learner method. First, today we have heterogeneous learners. You have a 20-year-old and a 55-year-old, both wanting to learn the same thing. In fact, I got a call from a daughter, please come in, Deepti. That's another Deepti, this is another Deepti, I hope this is not that one. So anyway, the point is that when we teach for a small number, or let's say our pedagogy or design is for teaching small numbers, then the moment more numbers come, it deteriorates. And if n is the number and you design for 1, it will become 1 upon n. This is a standard kind of a thing. If I design something where I don't care who the audience is, right? I'm saying bhaiyon or behnon, then it doesn't matter who many is listening, because I'm not talking to anyone in particular. Therefore, it is independent of n. I can have 1 million people, 5 million people, 10 million people, doesn't matter, because I'm not speaking to anyone in particular. But suppose, as we expect to happen today, we decided that we want a group which is n plus 1, and all n are equal members of the learning community. Then imagine what will happen. It will be n into n minus 1 upon 2 interactions that we are creating at 2 by 2 level, n into n minus about 3 at 3 level, and therefore you are having orders of n square and n cubed. So if I have 20 people, my experience or the outcome is going to be 800 times superior if I've allowed these people to talk. And I very often reflect on this. I was a good student. I taught in IIT Kanpur. What am I doing? I mean, all of you keep quiet and I will talk for 50 minutes. Now, if all those people were engaging in the discussion, and they're all bright people, younger than me, equally bright, maybe even higher IQs, what would have come? And this is the point that I'm trying to make as a third. We need to create a pedagogy of interactive, engaged community learning. And instead of finite learning, we have to make it lifelong learning. We have a very funny thing that everything we want in terms of finite and results. In pure philosophical economic terms, this is Jeremy Bentham's theory of utilitarianism. So I learned this, so I can use it for something. People like Socrates, you heard the famous story of Socrates. When he was dying the previous evening, he learned a new tune and a new instrument. And they told me, but what's the use of this? He says, so I know one more thing before I die. That is the other extreme. People like Bertrand Russell talk so much about the useless knowledge. What is useless knowledge today becomes very intrinsic and fundamental tomorrow. Many of you would remember in your school, if you studied prime numbers, it could only have been a source of terror. Today you cannot have information security without prime numbers and factorization of prime numbers and so on. And this is moving more and more. Everything that we talk about today is more and more of application of mathematics. Somehow, this difference between finite and infinite is very, very interesting and important, because we are also used to small numbers and finite things and a result, that everywhere we say, if you're not getting a result, give it up. So much so, how many of you remember that movie called Gumrah? Gumrah has a very interesting sentence with a closing line, वो अफसाने जिसको अंजाम तक पहुंचाना न हो मुमकिन. See, this is what we talk about learning. अगर इसको पढ़ के तुम आगे नहीं जा सकते, कोई नौकरी नहीं मिल सकती, इंजीनियर नहीं बन सकते, डॉक्टर नहीं बन सकते, छोड़ दो इसको. See, why can't learning be an infinite pursuit lifelong? Some of things you master, some things you don't master, some things you really appreciate the challenge. And just like love is to be constrained into finite, which would mean marriage, children's wedding, etc., etc. But why can't it be infinite? And I think this is a very important issue that I was trying to tell informally. As humans, we were used to a very finite thing. You know, the Romans would do up to 10 and then they would do 10, 20. They could not even imagine a million easily. So our world was finite, small. We were comfortable with that. Then we moved to a little more. Today we are talking of everything being very large problems. We are talking of global warming. We are talking of climate change. We are talking of the Arctic meltdown. We are talking of going and colonizing other planets. It's a completely different game. It's all a game of very large numbers, almost in terms of infinities. And this is to me where the big shift is from the traditional education, which was more of concrete things. Can you add 2 and 2 or not? To today, can you extend the meaning of what addition is? And when you are learning addition, you learn scalar, vector, metric, etc., all simultaneously, that whenever you put 2 things together, what happens? There was an attempt at this once upon a time. I don't know how many will remember when in mathematics we were trying to talk about set theory. And that was being introduced very early in the stage, but the mafia kind of brought back to this current thing. So the issues or the suggestions that I'm making is from finite learning to lifelong learning, and from goal-based thing to open-ended thing. So earlier the idea was that a few people will explore problems, do research, push the frontiers of knowledge, and other people will apply it into a routine kind of a thing. That thing is going to become less and less, because application to routine thing will be done by machines. And machines, as we said, are getting more and more intelligent. And let me quickly spend a few minutes on this, because I want to finish sharply at 10, and we already have Kainer and Deepthi and everybody else for the next session. And everybody has very limited time, so sticking to time schedule is kind of very important. Now we all know about artificial intelligence and machine learning, and these are buzzwords. The problem with some of these words is that people extend a meaning to it, because these words were created by computer people. Computer people are very bad at language. They have no sense of, see, look at the doctors, any disease is an itis or a pneumonia or this or that. You look at lawyers, ubi jus ibi remedium, breast locator, all that. Computer people input, output, print, this, that, very boring. And then adopted this word intelligence without even knowing what it is. See, even human intelligence we can't define. Those of you, yeah, you have psychologists here. So at one time, the Stanford Binet test was the test for intelligence, and the word IQ, which was the ratio of the intelligence actual and chronological age. If your IQ was 120, 140, 160, you were very bright. Then came Howard Gardner. He screwed everything up. He said there is this intelligence, that intelligence, 7 types of intelligence, and kept scope for spiritual intelligence. And if Amit Shah had any educated people as advisors, he would have called him electoral intelligence. So Amit Shah is the highest one on election intelligence, right? There is no doubt about it. You can call them 100 upon 100 and then say who are the others. So intelligence is a manifestation of some activity which is not purely what you would call autonomous or reflex behavior. So this is one of the big problems. And suppose there were some literary people in the computer group, they would never call it artificial intelligence. They would call it non-anthropic cognition. See, because anthropic means human, non-anthropic means non-human, cognition is about intelligence. So they would have called it non-anthropic cognition. Then it would have some big, thing about it, that this is here something. The psychologists as cognitive scientists would have come in and everybody. What has happened is it has now become misanthropic cognition. And what we want to do is philanthropic cognition. So the idea that this whole thing should be for the benefit of humans and aligned to humans is what is very, very important. So where does this thing start happening? If you look at humans, and we have enough biologists amongst us to know that for a zoologist, we are yet another species of animals. And Uttarakhand High Court has recently said that all forms of life have the same kind of a thing, and so we are animals. And if you put the taxonomy, Bhupesh will tell you, animal, chordata, mammal, etc., to Homo sapiens. So we are just part of the animal kingdom. But we are very interesting. At one level, we are physically and biologically very weak. One of the most, you have to protect them for almost 18 years, 20 years before they can be useful humans. All other animals start jumping around and do whatever their activity is very short. We can't fly like birds, we can't swim like ships, we can't run like horses, and so on. So everything is very weak. We can't even see very well. But we have a highly developed brain. And with that highly developed brain, and using some physics, If you have problem with your eyesight, you use a convex lens or a concave lens or a bifocal lens or a continuously variable focal length and set right your eyes. If you want to see something very small, you use a microscope, an electron microscope, and so on and so forth. You can go up to atomic sizes. You can't see very well, please come. You can't see very well, you can use a magnifying glass, a binocular, a telescope, a radio telescope, and you can see into all the galaxies, and you know that the Kepler telescope has gone and found another set of planetary systems and so on. So everything where God was against us and made us very weak, we used our brains to be able to understand what's around us, how the world works, and resolve issues. So we can live in very hot places by air conditioning, we can live in very cool places by hot. So we don't have that niche environment into which we can be, and today we are looking at space colonization. So this is one of the big things. The computer was an engine of the mind. So whatever weaknesses we had in the human brain in terms of doing our cognitive functions, which were 2 or 3, one of them was memory. All of us were like Gajani in some sort or the other, and therefore you have huge memory which you could put. And then when we found memory can't be put here, we put it on the cloud. So now all of us have access to infinite amount of memories, and so you don't have to worry whether you remember that or not. Sorting things, if you saw a book of 500 pages or a file of 1,000 pages, you would get rattled. Today now the computer will do it for you, organize, classify, etc., etc. And therefore we were able to make a lot more progress, and everything that we see today is because of that. The big shift, so in a traditional computing, what you have a program which is an algorithm to solve a problem, which is a step-by-step approach, written in a programming language which varied from Fortran from my times to Python today or C++ or whatever you like. So you have a data, which is a set of issues which you want to solve a problem, an algorithm, a program, a computer, and out come the results. What has happened in the last few years, has happened means has been physically realized. Theoretically it was for a long time. So when I started computing, there was a tribe like me who would use Fortran for scientific problems. There was a tribe like theirs who would use COBOL for business problems. There was a third tribe who nobody knew of. They were using languages like Lisp and Prolog and so on to solve artificial intelligence problems, create rule-based expert systems. But the computing power of that time was very limited. And they will create a neural network with 50 data points, kind of mimicking a doctor, but nowhere near a real doctor. Fast forward, we had faster chips, we had new methods of learning called machine learning and layered networks. So you had an input layer, output layer, a number of hidden layers. You had a lot more data available from the internet. So suppose I want to teach a program facial recognition. What pictures do I have? Typically at our time there would be a picture of your graduation ceremony, one your wedding ceremony as a couple, and then group photographs in various situations. So with 5 photographs of 10 years apart, you would not train any computer. Today you have millions of photographs of everybody on the internet, ImageNet, so on and so forth, so you can train the computer. So what are we saying? The new AI, machine learning, deep learning, which are all subsets of AI, allows a computer to learn by itself. So till yesterday, no matter how much you worked on an Excel, you would do the same thing again and again. Today, when you do something on any of these things, that if intelligence has been implanted into it, they will be able to analyze. No, this is not right. You spelled Bhupesh as B-U, no, B-H-U is what you have to write. All this kind of thing is coming because the computer is learning. How does the computer learn? It basically does a number of steps. It can do a classifier. So it can classify things into 2 categories, number of categories, and so on. It can therefore then predict that this is the kind of thing that it can understand a large part of your grammar and so on. So it can do classifier, it can do identification, it can do matching, and so on in many different ways. Where you don't. We're all fascinated with the computers playing chess, but chess is a set of defined rules, although the combinations are huge and very few humans are able to process that with that speed. But IBM Blue did it long time back and then was. But today, when AlphaGo won its championship against human Go players, it was not a set of complex algorithms. It did not even have training data in the traditional sense of the word. It played a few games, created that data. From that data, it interpreted what does it take to win and move on. On a fundamental level, does teaching exist anymore? If a computer can learn how to play Go, can it not learn how to solve the Pythagoras theorem or a quadratic equation or a linear equation? And cannot humans learn it by themselves? So what I'm trying to say is humans with the aid of AI can do a lot more. And now let me come to the challenges I said. The first challenge was training millions of people. Second challenge was in new topics which nobody knows. So one of the big problems today is that you want to train 1 million people in, let us say, deep learning, etc., which Vishal is trying to do. He trains a few hundred at a time. It will be several births before he can train 1 million people in this thing. So that's the other aspect. So training a large number of people in a very short time on new things which nobody knows. And that is why AI in education is the answer. It is not on the traditional thing or coaching for IIT, JEE or whatever, which people are doing, and then you can do anything for practice. But the real answers are going to come in something like that. The second part is that then in pushing the frontiers of what more can be done, which is better than the best of traditional education. So this is the kind of a challenge that we've taken upon ourselves. The good news is that the first few steps in this direction can be taken quite easily. China has made it compulsory. They've already designed a course for students at the school level for AI and machine learning. Canada has done it. England had done one on computational thinking and programming a few years ago. So the world is now moving to the idea that you don't have to first pass class 12, then go to some university or some AI, then you start your career in machine learning. You can start usage of that across. Andrew Ng, who's one of the greatest people in this field, has a very famous quote that AI is the new electricity. And what he implies by that is that everybody or almost everything which needs to become more efficient will get augmented by AI, and therefore that is something which is going to be very important. It is very clear on one day's deliberation like this we cannot get all the answers, nor do we have any intention of being able to do that. But this is a very interesting opportunity for us to share things we already know about, and in the forum that we created we shared lots of resources and reports from Pearson and this and that and so on, and then we can try to align it to our own concept. One of the actual products that I hope to get out of this is to be able to create something which we can do for all school children. And the idea is that let the formal CBSE and CRT talk of doing all the old things for the people, etc., according to their things, but let us use outside the school hours and the mobile phone for them to learn everything that is useful. And it is interesting that some schools seem to appreciate this idea, that let us now have, see, actually flipped learning, if you remember, created this idea that you can learn something outside school which is also related to school. So what we are talking of is that let children learn in school whatever the power that we think is important, and they continue it. But outside school, instead of being drifters and spending time on things which are not so useful, they can actually work towards this. And I'm kind of working on designing a curriculum for class 11 students, because still class 10 let them do the board, class 12 board is still a little away, and that is the time when they can start reflecting upon themselves, becoming lifelong learners, understand this and this. And what will happen is that by the time they pass class 12, they will be better decision makers, because they've now seen that you can use data to predict. So you can predict what is going to happen to me, what is happening, etc., etc., because predictive is the interesting part is, and I've seriously gone through the curriculum of 11th and 12th. Everything they need to know is already there. They are taught algebra, they are taught calculus, they are taught probability, but they are made to work on boring problems by hand till they get disgusted and tired with this thing. So if they can solve two simultaneous equations with two unknowns and coefficients given, we just say that if you can do this, if there are 10 unknowns and 10 equations, the same thing can be done. This is easy to do by hand, you do that, but the same Gauss-Jordan elimination method could be actually used, and the computer will do it for you. no problem then becomes too difficult for you to do. So I think we've got now a full house also, and it's time 10 o'clock. So can I request Kainar Sajdev to... We have a tremendously talented group here, and many of them have introduced themselves, and yeah, come in, I'm just saying why you are coming. So.